there, math learners! We are the House of Samson, and today we are diving into the world of antiderivatives and indefinite integrals. Sounds complex? Don't worry, we got you. By the end of this lesson, you'll have a solid understanding. So, shall we begin? First, let's talk about antiderivatives. You've learned that differentiation gives us the derivative of a function. But what if we wanted to reverse that process? Now that is where antiderivatives come in.
An antiderivative is a reverse of different function. If different functions give us the rate of change of a function, an antiderivative tells us the original function before differentiation. Problem: find the antiderivative of f of x is equal to 2x. Solution: define a function f of x such that f of x is equal to 2x. We call the derivative of x squared is 2x. So one possible antiderivative of f of x is x squared. However, since the derivative of a constant is 0, general form of the antiderivative is f of x is equal to x squared plus c. This c represents the constant of integration, and it's crucial because differentiation removes the constant.
Segment 2. Indefinite integral. Now, let's talk about indefinite integrals. The notation we use for antiderivatives is the integral sign. The indefinite integral of f of x is written as the integral of f of x dx equivalents to f of x plus c. This simply means we are finding the functions whose derivative is f of x. Example: the derivative of 3x squared dx equivalents to x cubed plus c. Just like before, we add c because multiple functions can have the same derivative.
And now, let us discuss about the power rule. It helps us integrate expression where x is raised to a power, or denote as antiderivative of x raised to n. Now let us see it in action with an example. If we have an example of x raised to 3. First is to identify the exponent. If we have x raised to 3, so our n is equal to 3. Second is to apply the power rule. Now we denote this as antiderivative of x raised to 3. So it equals to x raised to 3 plus 1 over 3 plus 1 plus c. And lastly, we must simplify it all. So you're going to have the final answer of x raised to 4 over 4 plus c.
Now let's move on to the rule number 2, which is the constant rule. The integral of k dx is equal to kx plus c. For the second example, solve for the integral of 5 dx. Since 5 is a constant, we can simply multiply it by x. So the final answer will be 5x plus c.
To recap, today we learned that 1. An antiderivative is a function whose derivative is f of x. Number 2. Indefinite integrals use the integral sign and include a constant c. 3. We follow basic integration rules like the power rule and the sum rule.
Thank you for watching. Keep practicing, and soon integration will feel like second nature. See you in the next episode.